All right, today we're going to talk about different kinds of symmetry, and we're going to be looking at three types: line symmetry, point symmetry, and rotational symmetry. So let's start with the first one, line symmetry. And you have seen this before, you've done it before. Line symmetry, if we look at the definition, it says if the figure can be mapped onto itself by a reflection in a line. So basically, what they're talking about, okay, the hint is think of a mirror image, but what they're talking about is can you draw a line through your shape that will split it into two equal parts, and can you draw a line where if you were to fold it, that the two pieces would match up exactly. So if we look at this triangle here, you got to kind of look at your different options. If we try to draw a horizontal line, okay, that does not cut the figure into two equal smaller parts. And if you visualize it folding at that line, the two pieces would not match up. So that would not be a line of symmetry. If you decided you wanted to come through the corner here and draw a line, okay, again, it does not cut your shape into two equal smaller parts, and if you were to fold it, your two pieces would not match up exactly. Let's try right here. Okay, now if you look at this line I just drew, you can see it does appear to cut it into two smaller equal parts, and if we were to fold it on that dotted line, the two pieces would match up. So we would say, yes, this triangle has line symmetry. You only need one. All right, the second type of symmetry we're going to look at is point symmetry. Point symmetry is a little bit different. Point symmetry occurs if the figure can be mapped onto itself by rotating it 180 degrees. Okay. And what they mean by rotating it by 180 degrees is you turn the figure upside down and it looks exactly the same as what you started with. So take your paper, turn it upside down. So technically it's 180 degrees. It's two turns of your paper. And you will see that this end will look exactly the same. When you turn your paper, it looks exactly the same as this original picture right here. And when that happens, you say it has point symmetry. If you can turn it upside down and it looks exactly the same. And point symmetry is actually a special kind of rotational symmetry, which is what we're going to look at next. Rotational symmetry. A figure has rotational symmetry if it can be mapped onto itself by rotating a figure less than 360. Okay. Now, what that means is as long as you can turn it less than all the way around, 360 is a complete turn, so it would be 4 turns of your paper. If you can turn your paper less than that and get the exact same shape that you started with, it has rotational symmetry. So if you look at, kind of looks like a sun over here. If you look at this picture, take your paper, start to turn it. Okay, there's no set amount, but just start to turn it. And if you turn it, okay, you will see pretty quickly that it looks exactly like the original. Okay, if you turn it just enough, you'll see. Okay, and you didn't have to turn your paper all the way around to where you do a 360 degree turn. You just had to turn it a little and it looks exactly like the original picture. You say it has rotational symmetry. So we're just going to do some examples, okay, and see what we have. All right, in number 1, we have, that's actually a hexagon. And so the first thing that we want to check, does it have line symmetry? Now line symmetry, again, can you draw a line that cuts it into two smaller congruent parts, and or where you could fold it on that line and have your parts match or overlap exactly. Okay. And so there are different kinds of lines of symmetry. So if I draw, this is a vertical line, you can see that that cuts that hexagon into two smaller equal pieces. If we visualize folding it on that line, they would match up exactly. So this has a vertical line. Some of you might say, well, I looked here and I saw the horizontal line of symmetry. Absolutely, that would also be a line of symmetry. The other way you could do is you could go diagonal. Okay, and the problem here with the hexagon, if we went diagonal, well, let's draw it. That way, actually, if we were to fold it, your parts would match up exactly. They're two smaller equal parts. And you could also go this diagonal. So this does have a line of symmetry. It actually has 4. Okay. The vertical, the horizontal, and the 2 diagonals. So yes, this hexagon has line symmetry. Now remember, point symmetry is if you take it and turn it upside down. So take your paper, turn it upside down. Does it look exactly the same? The answer to that would be yes. Now, if it has point symmetry, it automatically has rotational symmetry. Because remember, the definition for rotational symmetry is that you can turn it less than 360. Okay, and we've already proven that if you turn it 180 degrees or upside down, it does have point symmetry. Point symmetry is a special type of rotational. So we would check rotational. All right, let's look at number 2. Number 2 is a triangle, and let's see if we can draw a line of symmetry. So let's say you start here and you start drawing a horizontal. Okay, I think you realize pretty quickly, oh, that's not a line of symmetry. It does not cut my piece into 2 smaller equal parts. If I were to fold it, they don't overlap. So horizontal won't work. But what you don't want to do is just say, oh no, it doesn't work. We need to check, can we draw a vertical line of symmetry? And the answer to that is yes, we can. Okay. 2 smaller parts that are equal. If I were to fold it, they would match up. So then I also need to check the diagonals. And that diagonal would work. And so would this diagonal. So once we just found the vertical, we could check line. But just be aware, sometimes they may ask you how many lines does it have. So you don't want to just draw one and stop. Okay, you want to check all your other possibilities. So now we got to check if it has point symmetry. So take your paper, rotate it 180 degrees, which is upside down, 2 turns of your paper. And what you realize when you rotate it 180, your triangle actually looks like that. Okay, and while it's still a triangle, it does not look like the picture that we started with. So it does not have points. Okay, does not have points. Now we have to check if it has rotational. We know we can't rotate it 180 degrees, okay, because that gives us a different perspective or picture of the triangle. But if we continue to turn it, okay, or if we go back, center your paper, get your paper the way it should be, and start turning, you will see at some point it does look like the original, so it does have rotational. Okay, so no point, because when you rotate it 180 degrees, that is the picture that you get. It does not match, but it does have rotational. All right, number 3, okay, that's a parallelogram. So we have to see, does it have any line symmetry? So if you try to do the vertical, okay, vertical does not work. Okay, let's try the horizontal. Now be careful here, because some people do think that the horizontal works, but if you actually were to draw that on a piece of paper and fold it on the dotted line, your pieces would not match. So that doesn't work. Let's check the diagonal. Okay, again, if you're not a visual person, then you might want to actually sketch this and fold it. But that one also does not work. So this does not have line symmetry. Looks like it would, but it does not. Now, if we take it and turn it upside down, we have to decide, does it have point? 180 degrees, which means turn it upside down. Okay, and again, since you have your paper, obviously I cannot turn my screen, but since you have your paper, it's probably easier for you to turn your paper. So turn your paper upside down, compare your pictures. Do they match? Yes, they do. So this parallelogram has point symmetry, and we already said if it has point, it defaults to rotational. Because rotational just says, it doesn't say specifically 180 degrees. It just says less than 360. All right, so let's look at number 4. This is a right triangle. So line. Can we draw a line anywhere that would cut that into 2 smaller congruent parts? Or have a mirror reflection? So vertical, nope, vertical doesn't work. Horizontal doesn't work. Diagonal does not work. So that would be a no for points. None of those work. Oh, sorry, a no for line. All right, take your paper, rotate it 180 degrees, turn the shape upside down. Does that shape match the original? The answer to that would be no, because when you turn it upside down for point, what you end up looking at is your right triangle looks like that. Okay. That is not what your original looks like, so no to point. Now, let's see if we can rotate it at all, as long as we don't come back around to where we started and have the same shape. So actually physically rotate your paper, rotate it slowly. Stop if you get it to look exactly like the original. Okay, so I'm rotating, and the only way I can get it to look exactly like the original is if I do a full turn of my paper, which is 360 degrees. So this actually does not have rotational. It has to be less than 360. So this picture has none. All right, number 5, we got the star. Let's check line. All right, I always like vertical and horizontal. That's usually where I go first. Okay, yep, that one works. Now, again, is that the only line of symmetry? No, this actually, you could come out of every point of your star. Okay. So you may not have started there with the vertical. I just do vertical or horizontal first usually. But if you look, you have lots of lines of symmetry here. And again, you don't want to just do one. Okay, be aware that there's sometimes more than one, because sometimes they'll ask you how many does it have. Point symmetry. So what you're going to do is you're going to turn it upside down and see if it looks exactly like the original. So what will happen is, and again, I recommend turning your paper. What will happen is this bottom part right here, if you turn your paper, actually ends up at the top, and the point right here actually ends at the bottom. So that means it does not have point symmetry. Okay? The pictures do not look exactly the same. Now, turn your paper back to normal. Just start rotating it. Can you start rotating it and get the picture to look exactly the same? And again, there's no set degree here. But if you start rotating your picture, you will see at about 45 degrees, maybe 60 degrees turn, that your star looks exactly the same as the original. So it does have rotational. All right, this weird little shape here, it's just kind of a design. We have to decide if it has line, point, or rotational. And so if we look at it, again, I would actually try to draw my lines, okay, and you can always erase them. So if I draw a vertical, nope, if you were to fold it, those pieces would not match nor overlap. So vertical line symmetry doesn't work. Let's try horizontal. Okay, again, if you were to fold it, your pieces would not match up, so horizontal does not work. We could try diagonal. Let's see. Again, that's a no. Okay, and if one diagonal doesn't work, the other one will not work either. Well, let's try it though. I might have just misspoke based on the way this picture is drawn. All right, so if we do that, and I'm actually gonna cheat for a second, and I'm going to trace, because I can't really tell. And anytime you can't tell, you can do exactly what I'm doing. You can actually get a piece of paper and trace it, and then fold it where you drew your line of symmetry, and see if your pieces match up. Okay. And when I fold it, my pieces do not match up, so it doesn't have line symmetry. So this shape has no line symmetry. Does it have point symmetry? Okay, again, take your paper, turn it 2 turns. Do you get the same shape? And this is a trick question, so be careful. I don't know if anybody... Okay. Yes, it does, doesn't it? You have to pay attention to all of the little pieces. Like these pieces, you got to make sure they're in the same spot. Everything has to match up exactly with the original. Now, we already said if it has point, then it automatically has rotational because you just turned it 180 degrees, which is less than 360. And so, yes, it has rotational. All right, the letter A, you'll find that they like letters, okay, especially these 2-dimensional letters. Can you draw a line of symmetry? Okay, if you go horizontal, very quickly you see, nope, if I fold it, okay, they wouldn't match up. They are not mirror images, so no to the horizontal. But again, don't stop there. Okay, check vertical and diagonal before you make a decision. So here's my vertical line of symmetry. Okay. Yes, those are mirror images. If we folded it on the dotted line, they would match, so it does have line symmetry. It has vertical line symmetry, but not horizontal. Point. Okay, so take your paper, turn it upside down. Does it look exactly like this? Nope. What happens? Your A is completely upside down, so it does not have points. Rotational. Okay, so go back, look at your picture or your paper like it should. Start turning it slowly. Can you get, as you turn, the exact same picture as the original? So turn it, turn it, turn it. And what you'll find is you actually have to do a full 360 before it looks like the A. And so, nope, it does not have rotational either. Okay, so it has line. It's the only kind of symmetry it has. All right, number 8, lightning bolt. So we got to decide line, point, rotational. Okay, so again, I try vertical. That would be a no. Horizontal. That would be a no also. They're not mirror images. You couldn't fold. You could try diagonal. And nope. And the other diagonal, no. So this does not have line symmetry. All right, does it have point symmetry? And again, you just turn your paper upside down. Okay, just take your paper, turn it upside down. Does it match the original picture? Okay, turn it upside down. And that would be no, right? If you turn your paper, because notice this is pointing, the end of it is pointing to the right on the original. If you turn it 180 degrees upside down, your lightning bolt, or whatever you want to call this, is actually now pointing to in the other direction. So no point. All right, now we got to check, does it have rotational? So again, start with your paper in normal position. Just start turning. Can you get it to look like the original without coming all the way back around? Going 360, okay, and turning, and that would be no. Okay, the only way you get it to look like what it looks like is 360 degrees. So this one actually comes out to be none. All right, this next page, I want you guys to try and then come back, watch video 2 so you can check your answers.